All right, so the lesson today is on 13.5, Laws of Reflection. Most of us have a fairly good idea how mirrors work. Here we will formalize these ideas by doing what we will be able to... what does that say? Here we will formalize these ideas, and by doing so, I think there should be a so in there, we will be able to study them better, okay? So we're going to study how mirrors work. A mirror, first of all, is a smooth surface, and it reflects light in a very predictable way. So I'm going to just highlight a little bit of this for you. You might add to your notes. You've already made some notes on this section already. But a mirror, or a other smooth surface, reflects light in a predictable way. This is called specular reflection, okay, a term that might not be in your textbook, specular reflection or direct reflection. Okay? A rough surface will scatter light in a random way and is called diffuse reflection. So if we have a rough surface, it's diffuse reflection. To diffuse means to spread apart, right, and go kind of different directions, not all the same direction. So it means to spread apart. And you can think of an example, like if you have a nicely polished mirror, like in your bathroom at home, probably all of you looked at yourself in the mirror today, right? Is there anyone that knows for a fact you did not look at yourself in the mirror today? Matthew? Okay. If you, you gotta do your hair. Anyways, no, we all look at ourselves in the mirror every day, at least once a day, right? There's some kind of reflection. Now you also, if you walk by a storefront or something, and maybe they have like frosted glass or something, or maybe in your house your front door has some frosted glass or something. If you can see a vague reflection in the glass in your house, and then you go to the frosted glass and you can see kind of a rough reflection, or even if there's a mirror behind that frosted glass, that glass is not uniform, and it's scattering the light in different directions, so you just see kind of a vague shape of yourself. That's diffuse reflection. Okay, so we'll now take a look at the diagram on page 418 and go over just quickly some of these terms. All right, the incident ray. The incident ray is the ray of light that hits the mirror. Here's the diagram below. And the incident ray would be right here. This is the incident ray. So if we're considering one ray of light, we can talk about the characteristics of the reflection of light, and all of these terms are going to be important. So this is the incident ray right here, and it would be what would be a single ray of light that hits a reflective surface. So this is the incident ray. The reflected ray is the ray of light that bounces off the mirror. That's pretty basic, right? Incident ray is coming to the mirror. You have an incident, right? It's an occurrence. So this ray is coming. And reflected is sort of the result. It's the reflection. So this would be, over here, the reflected ray. Right here. Okay, so when I say incident ray and reflected ray, you guys know what I'm talking about, right? Ray of light that comes, hits the mirror, and bounces off is the reflected part. The point of incidence. Okay, the point of incidence. This is the part of the mirror that the light bounces off of. So if we're talking about this incident ray, it strikes the reflective surface at the point of incidence right here. Okay, so that's this point right there. The normal. Okay, so this is something that you probably haven't heard of before. The normal is actually an imaginary line that is 90 degrees, that forms a 90-degree angle to the surface of the mirror from the point of incidence. So, let me see. I don't think that was explicitly explained in your notes, so you might have to take a minute to write this down. But it's an imaginary line, forms a 90-degree angle to the surface of the mirror at the point of incidence. So here's the normal, and the reason why this is important, somebody's asking, why is this imaginary line important? Well, what we're going to see is this is the basis, this line right here is the basis for calculating angles of incidence and angles of reflection, which we'll talk about in a minute. But you see, here's the point of incidence, here's the reflective ray, if we take a look at, this angle right here with this line and the mirror, that's a 90-degree angle, right? And so that normal would be an imaginary line that we will use primarily for our diagrams to show and to calculate angles of incidence and reflection and stuff. Okay, so there you go, normal, if you haven't written that down yet. And again, the normal helps us to calculate these angles. The angle of incidence would be the angle between the normal and the incident ray. That's pretty straightforward, isn't it? The angle of incidence. So when a light ray comes in and strikes a reflective surface, the angle that we are concerned with, that we're going to use in our calculations and descriptions of all this, is the angle between the normal and the ray. Now what most students mistake is they actually mistakenly call this the angle of incidence, because in math you always use the horizontal line and then your angle line. This is not the angle of incidence. Okay? The angle of incidence would come measured from this imaginary normal line out like that. Okay? So just a note, the angle of incidence is right here, and it's denoted by a lowercase I. The angle of reflection is the angle between the normal and the reflected ray. That's the angle of reflection, and of course in the diagram it's this lowercase r right here, angle of reflection. We look at the laws of reflection on page 19, and they're in bold terms there. It says the angle of incidence is equal to the angle of reflection. So because light travels in straight lines, whatever angle that this incident ray comes in at, it will leave at the same angle. Now some of you may be asking, well, aren't these angles equal as well? Yes, they are. This is not the angle of incidence, but whatever angle this is, it would be 90 minus I. Yeah, these would be the same in the diagram as well. Okay? But anyways, whatever angle it comes in at, it also leaves the surface at. And the other part of it, of these laws of reflection, are the incident ray, the reflected ray, and the normal all lie within the same plane. They all lie within the same plane. When we talk about a plane, this is like the mathematical plane. This is not a flying plane. This is like a mathematical plane. So if we're talking about the same plane, a two-dimensional plane would be the x and y axes. If you're looking at the screen, like literally this screen right here, this is a two-dimensional plane of space. There's another plane that we typically refer to in math. It's the z plane, right, or the zx plane, and that would be the horizontal plane coming out here. So these three lines always lie within the same plane. So if you have an angle of incidence here, angle of reflection, and the normal, then these are all in the xy plane. This, it's hard to draw. I'll show you a diagram in a second, but if this angle comes in here like this, the reflected ray is not going to be coming out, at some strange angle towards you, okay? With the normal here, the incident ray here, and so on. So it's all in the same plane. So here's the diagram. It's a better diagram than I could draw. But you see how the incident ray, the normal, and the reflected ray are all in the same plane of space. You don't have a ray coming out like this, right? Or back like this in this plane coming at you, right? It's all in the same two-dimensional plane. Okay, does that help? All right. As well, by means of explanation, all three of those lines can be drawn on the same flat surface. (13.6), same page there as on page 419. Images in a plane mirror. Okay, when we're talking about looking into a mirror and you seeing yourself in the mirror, that image, let's talk about images and characteristics of those. When you look into a mirror, you see your image. There are some rules for how that image appears. We can predict, based on where the object is, where the image will appear. A plane mirror is the simplest mirror to understand. A plane mirror is a flat mirror. It's not the parabolic mirrors that you see in grocery stores in the corner or in hospital hallways. Or it's not, curved mirrors that you see at the fair or something in the fun house that make you look tall or short or fat or wavy or whatever. We're talking about plain flat mirrors, just like the mirror you would see above your sink in the bathroom. The reason why we're going to talk about that kind of mirror is because the rules for the laws of reflection, when we talk about the physics aspect of it, those rules are really simple. The math behind that is really easy. So, first we must understand a little bit about how we see. Okay, now this is very important. Remember we talked about the nature of light and what Plato and Socrates and Aristotle and all those guys thought about what light really was? We must understand that an object will reflect light in all directions. So you see this picture of a candle here. Okay? It doesn't matter where you are, here or up here or over here, behind, in front, whatever, you would be able to see the candle. If there was 100 of you in the room looking at the same candle, all of you would be able to see it at once. And that's because the rays of light shine in every direction from the candle. So an object will reflect in all directions, but we only see the light that passes through the narrow window that is our eye. That makes sense, right? You're looking at me right now, you're looking at the screen right now. Okay, the light that is reflecting off of me and the screen, that light that is going to your eyeball is the light that your brain interprets, right? You can't see the exact same rays that someone on the other side of the classroom can see. Now, they're probably seeing the same thing as you because there's really not much difference between the reflection of light through, this half of the classroom and through that half of the classroom. So, but you can imagine that from different perspectives, you see different things. That's why those little, those little holograms or the little, I don't know what you call them. There's a bit of a diffraction gradient there that, little toys like little cards, and you turn it and there's one picture, and then you turn it the other way and there's another picture. Okay, that kind of thing. That's a little bit same sort of thing. Like when you turn it, the light is reflecting a different way and you see different parts of that little toy card. But there's light coming out from all different directions. So when we talk about drawing a diagram that represents how we see something in a mirror, first of all, the diagram is called a ray diagram. And that's going to include a diagram of a mirror, an observer, and that's just going to be represented by an eyeball here, just like this right here, and the image. And we're also going to draw the object as well. So you see the eyeball, you see the mirror, you see the object and the image. So you should put object in there as well. Mirror, observer, image. Okay. You don't have to have the object in the diagram, but we always will. So let's just write object. On page 420 in your textbook, they have diagrams that are similar. I am going to require just something a little bit different for the ray diagrams that you draw for me. You'll see in the diagram in the textbook that there's only one sort of reflected ray of light, or one point of the object that is represented. I'm going to get you to do two parts, okay? So that'll become more clear as we move on. But this is an example right here of a ray diagram. And this is a diagram to show how a person, here's the eyeball, how a person sees the reflection or the image of a candle in a mirror. And I want you to notice a couple things. That these lines are all straight lines, and they are straight to the surface and they bounce off. The angles are going to be the same, incident and reflected. And we have a mirror here, and behind the mirror, in a plane mirror, we're going to see the image. So the image is going to be behind the mirror. So let's just kind of take apart this diagram a little bit more. Unpack it a bit. So when we're drawing a ray diagram, the mirror is drawn with a solid line and little dashes like you see here behind the side of where the image appears. So on the back side of the mirror is where these little hashed lines are going to go. So behind the mirror. On the same side that the image appears to be on. The object in the diagram is drawn with a solid outline. So you notice the candle here is solid outline. So it's a candle, or it's a tree, or it's a ball, or whatever it is. The object is solid lines. The observer is drawn as just a single eye. You can get as creative as you want, but something that kind of looks like this. So here's an example of the image that's in your textbook, right? So I just copied this out just to show a couple other things. The image is drawn behind the mirror, and it's tough to tell here, but it should be in a dotted line. So the image is drawn with dotted lines, not with solid lines. The object will be with solid lines. The image will be with dotted lines. And in a plane mirror, the distance here between the object and the mirror is the same as the distance between the mirror and the image. Anything that's behind the mirror is drawn with dotted lines. Okay, anything that's behind the mirror. Okay, so behind the mirror we have dotted lines. We are going to draw two light rays, or two rays from the observer. Two. Here there's only one. There's only one shown. That's from the top of the candle to the eyeball. I know there's two lines, so each sort of like ray of light is going to be shown, I guess, in best as we can, sort of three-dimensionally. Okay. Converging at a point. So the eyeball is seeing one point. These lines here, you're going to go from the top of the eye and from the bottom of the eye. So in this diagram, and I want you to use a ruler when you do this, and I don't mind if you draw from the edge of your eyeball here too. You'll see in my diagrams that's what I do. In this diagram, they just draw from the top of the iris there. But it's a straight line towards the mirror, and it's the same, each line has the exact same angle of reflection, and they converge at a point at the image. Okay, so here's an example of a ray diagram that we're going to draw, and we're going to draw the image behind the mirror, and we're going to draw how the eye sees the image. Okay, so just to make this easy, what we're going to do is we're going to sketch the image first. We know characteristics about the image. The image is the exact same distance from the mirror as the object is. So in this case, this distance here is about 1, 2, 3, 4, 5, and a little bit squares. So I'm going to go 1, 2, 3, 4, 5, and okay. So the tip of the tree is going to be here, the exact same distance, right, from the mirror as the object. Tip of the tree. The base of the tree. Also, this is going to be 90 degrees, right? Like these rays here. So you are doing this. I'm copying this down. So this distance as well, okay, from about here, directly beneath, there's the bottom of the tree. Now the image is going to be dotted, and it's going to be, as best you can, you're going to draw the image. Oops, I got a little bit sideways there. Okay, here's the image, right? Bottom of the image. Dotted. And what we're going to show is we're going to show how the eye sees this. Okay, so what we're going to do, and it's going to be a little tough for me to do this on here with you, but from the top of the eye, okay, don't draw this yet, but from the top of the eyeball to the top of the image, okay, this is how the eye sees the image. Now, this line should be dotted here, okay, but that's literally what you're going to do. Draw a straight line with your ruler from the top of the eyeball to the top of the image. It's dotted behind the line. You're then going to draw another ray from the point of incidence to the top of the tree. And like I say, this might be kind of tricky for me to actually do on here to get it exact. Okay, so that is not exact, but we're going to fake it there. Okay? We'll just make that part of the mirror. Okay, so here's the point of incidence. You see that? And all of these angles should be equal. So here's our normal there, our normal there. Notice that this angle of incidence, and the angle of reflection should be the exact same. Okay? And we're going to do the same thing from the bottom of the eye. So bottom of the eye to the same point at the tip of the image. And then from here, where it intercepts the mirror, also to the tip of the object, right? There you go. Yeah. And it's dotted behind the mirror, so dashed lines here. And this is where you need a ruler, okay? You need a ruler to make this line, to make these lines. And again, notice that all these angles, I and R here, should be the same. They're not going to be the same as this I and R, but they should be the same. And then what I need you to do, just as we finish, you are going to finish this, but you are going to also make a set of two lines here from the eyeball to the bottom of the image, and I'll just get it started for you. You're going to do the exact same thing to the bottom of the image. This is due tomorrow. It's going to take you like a minute and a half to finish. So yeah, finish this for tomorrow, and do another set of lines here from the eyeball, the tip of the eyeball to the bottom of the image. Okay, so have that done for tomorrow. That's barely called homework. Dismissed. So this is what the ray diagram should look like, with the rays going to the top of the image and to the bottom of the image.